Okay, so this is homework 11, problem 2. And so we're given two stochastic processes, x of t and y of t, and these two processes are said to be jointly stationary in strict sense. And knowing that, we have to prove that the autocorrelation of yx of negative tau is equal to r of xy of tau. And so strict stationary means that x of t is just equal to, so x of t and y of t, given a time shift t1, the same time shift, both x of t is going to be equal to x of t plus t1, and y of t is going to be equal to y of t plus t1. And so, for example, if we're given that the expected value is x of t and y of t, that is also going to be equal to the expected value of x of t plus the time shift of t1 times y of t plus the time shift of t1. It's also important to note that even though these time shifts must be the same, the t's don't have to be. So the initial position can be different, but just the time shift has to be identical. And so applying this knowledge, let's say that r of x of y is equal to tau. R of x of y of tau is equal to the expected value of x of t plus tau times y of t. And so because they are strictly stationary in strict sense, then we can add or subtract the same time shift tau, and this will still become equivalent. So in this case, we want to eliminate the tau here, and so we could do that by subtracting tau on both the x of t and the y of t. So subtracting that makes these taus cancel out. And so it's going to be the expected value of x of t times y of t minus tau. And because this is a product on the inside, this can simply just be flipped. So it could be the expected value of y of t minus tau times x of t. And this here is simply just the autocorrelation of yx, not x of y, of negative tau, because the autocorrelation is just the difference between these two functions. And the difference is still just, in this case, negative tau. And so it's going to be the autocorrelation of x of y of x is equal to negative tau. And so we've proven that the autocorrelation of xy of tau is equal to the autocorrelation of y of x of negative tau.